in this particular static problem, we have a 1 meter uniform wooden plank, and it says zero point 0.4 meters of it is hanging over the edge. And then there's this little squirrel. It's going to go from the left edge of the plank to the right side. And then it's going to start tipping it over. Okay, and it wants us to find how far can this squirrel go before the system starts to rotate. All right, so this is a static torque problem. Because it wants us to find that critical value where it starts to tilt. All right, here are your answer choices A, B, C, D, and E. We're supposed to find this little X in the diagram. So here I gave you two diagrams to help you visualize. Here's a squirrel to start, and then it's gonna kind of start walking towards the right, and at some unknown distance, once again, it's gonna start tilting, okay, or tipping if you want. So I like to go ahead and identify my pivot. This way I can measure stuff relative to my pivot. So I'm just going to go ahead and label this little corner here of the roof or the flat surface there where the system is going to start tilting. So that's where the pivot, that's where the contact force is going to be. All right, so I'm going to label that my pivot. And then I want to go ahead and call the mass of the plank capital M here. I don't know what M is. I'm just going to call it capital M. And then the squirrel itself, it says in the problem though, it says the mass of the squirrel is half that of the plank. So I'm just going to call the mass of the squirrel little m. But little m is going to equal to the mass of the plank, which is capital M divided by 2. Okay, so I'm just going to make a true statement there. All right, once I have that, I'm just going to go ahead and draw my forces out and then find my R relative to the pivot and really just set up torque and be done with it. All right, so here's F of G for the plank. I'm going to put that at the center of the plank there, and that's just simply mass of the plank, which is capital M times G, acceleration due to gravity. And then here, this is the F of G for the squirrel, so I'm just going to call that FG squirrel, and then that is mass of the plank divided by 2, because that's the mass of the squirrel, times G. And then once I do that, I already have my forces here, as you can see. If you can visualize it relative to the pivot where my cursor is, if you pull down with the weight of the plank, the system will want to rotate counterclockwise. If you pull down with the weight of the squirrel, the system will rotate clockwise. So here we have a balancing act, whereas counterclockwise, clockwise, that are equal. Okay. Now that I have my forces, let's go ahead and find my R relative to pivot. So the problem says that the pivot to the right side is 0.4, but this is 1 meter long. So this purple arrow that just came up here, just using basic math, that'd be 0.6 because it's 1 minus 0.4, which is 0.6. But then, well, F of G for the plank is placed at the center, and this would be 0.5. Why is it 0.5? It's 0.5 because the entire plank is 1. Okay, so it's important that you can do these basic math skills here. And then, well, what is this last segment that touches the pivot? Well, it's 0.1. Okay, so once again, I'm going to run it. The whole entire plank is 1 meter. From the right side to where the pivot is given as 0.4. Therefore, the remaining has to be 0.6. But then you don't need 0.6, you actually need 0.1 because F of G is placed at the center, which is 0.5 away, but that's not your pivot. Your pivot is right here where this red dot is. So make sure you measure stuff correctly. All right, once I have that, I don't know what this distance X is, but I have my torque. So I'm just gonna set up torque. So my counterclockwise torque equals to my clockwise torque. The plank itself, once again, it's going to generate a counterclockwise torque. And then the F of G of the squirrel is going to generate a clockwise torque. So once you have this, just plug in statements that you know is true, right? F of G of the plank is simply the mass of the plank, which is capital M times G. And then what is R plank? Well, R is just measure relative to pivot. So take your, watch my cursor. I'm going to put my cursor there, and I'm going to go left where it touches the F of G there in blue, and that is already perpendicular. So that length there is just 0.1, and that's why that value in my work here is 0.1. On the right side, likewise, the mass of the squirrel, I don't know, but that's mass of the plank divided by 2 times G, and then whatever X is in the diagram, how far can the squirrel go before it starts to tip. So I'm just going to cancel M out because M is on both sides. I'm going to also cancel G out because G is on both sides. So as you can see here, you have 0.1 meter is equal to X divided by 2, right? So to get X by itself, simply multiply both sides by 2, and that's it. And it's kind of pretty straightforward. So the answer here would be 0.2 meters. Okay. All right. That's it for this problem. Stay nerdy. Don't be wired.